Over the last few years, consumer 3D printers have gotten a lot cheaper and a lot better. So it kind of makes you wonder, what does a $100,000 3D printer have that a $250 one doesn't? Which features and capabilities have already trickled down to us hobbyists, and which ones are yet to come? That's why for months, I've been seeking out some of the most popular and most advanced 3D printers on the market. And in this video, we're gonna find out just what differentiates them. Let's get after it. Before I get started, for the sake of transparency, I want to explain how I chose which printers made the list and which ones did not. First and foremost, I decided to only feature printers that I had in-person access to. I just don't think that it would be all that interesting or useful to show you screen recordings of manufacturers' websites without actually filming the machines up close or showing real sample prints. Now, unfortunately, that means that a few major brands are very noticeably missing from this video. As many of you know, I do my best to maintain a healthy working relationship with everyone in the industry, but I'm not perfect. I've made some really unfortunate mistakes and some pretty harsh criticisms in the past, and sometimes, no matter how much you try to make it right, people just aren't interested in giving you a second chance or even being associated with you at all. That's their prerogative. I've had to accept the consequences of my actions. I'm just sorry that it means that I can't present the full spectrum of machines on the market to you guys. On that note, I do also want to be transparent and say that although many of the manufacturers in this video have sponsored videos on this channel in the past, and I do have professional and personal relationships that inherently make me biased, none of these brands sponsored or paid to be a part of this video, though I will include affiliate links in the description should you choose to support the channel, but that's not going to influence how I talk about the printers. Finally, I'll add that just generally speaking, I tried to feature newer printers or printers that offer a unique value proposition at their price point to help highlight the additional bang that you can get for your buck at each different tier. But hey, if I omitted your favorite printer or a printer that you feel should have made this list, then please feel free to let me know in the comments below. All right, ethical stuff out of the way, let's get right into it, starting with $100. So this is the Easy 3D K7, and I picked it up on AliExpress for just under $100, shipped. So what are we getting for that price? Well, we get a cantilevered design, a build volume of 100 by 100 by 100 millimeters, and the ability to print up to 230 degrees. So basically exclusively the beginner's material PLA. That's about it. So for the sake of comparison to the upcoming printers, let's talk about what you're not getting. First, no spool holder that actually holds a full kilo of filament. No automatic bed leveling, no heated bed, no PEI spring steel build plate. There's no LCD or any other display to control the printer, just a few buttons for things like preheating or initiating the latest code on the SD card. Obviously, there's no Wi-Fi or remote operation at this price point. As for reliability, it's kind of hit or miss. You definitely can get good quality prints out of this thing, but not all that consistently. And print speeds are, let's just say, slow. Even though they do offer, quote, high-speed profiles for the most popular open-source slicer, Orca Slicer, things will typically take around 6 to 7 times as long to print on the K9. So, yeah, it's not a great machine, but hey, if this helps make 3D printing and STEM more accessible to kids, especially those from less privileged backgrounds, I am all for it. Which is why I think I'll be donating this to a nearby school so we can get on to our next printer. $250. Up next, I want to make a quick stop at $250 just because it is insane to me just how much value you can get at this price point nowadays. It's almost incomparable to the Easy 3D. It's still a bed slinger and an open printer, but already we've got a much bigger 255mm cubed build area. Print speeds and print quality are fantastic already. The same high speed and high quality as honestly most high-end 3D printers these days, even though sometimes reliability can be a little bit spotty. You're getting automatic bed leveling and flow calibration, allowing complete novices to print without hassles. It comes with a 320°C hot end and a 110 bed, allowing you to print some more advanced materials, but unless you purchase a separate enclosure, you're probably not printing any high temp or engineering materials just yet on this one. You do, however, get a touchscreen web access that allows you to control and print directly from the slicer, and you even get a cloud integration for remote access if you want it. But where this printer shines, even against others at the same price point, is going to be in the multicolor system. Yes, for just $259 and at just the second 3D printer on our list, you already get the ability to print with 4 colors with an optional upgrade to 8. But unlike other multicolor printers at this price point, the Ace Pro is both enclosed and features a filament dryer, which would easily cost $100 or more on its own. Heck, you even get a camera on the V2. So yeah, a lot of bang for your $250. It really makes me wonder just what kinds of features are we going to see on the $10,000 printer? But let's step it up a notch.
$500 to $1,000.
At $500, we are now firmly in the Core XY territory. In other words, printers that either ship enclosed or can easily be enclosed. These printers also offer higher speeds and more stability due to their design and kinematics, and they have a smaller footprint relative to their print volume. Heck, I'll even give an honorable mention and say that thanks to Elegoo, these days you can get into Core XY territory for just $300, though unfortunately they don't ship to my country, hence the omission. But what do you get if you jump all the way up to $500 or more? Well, let's have a look at the Anycubic Cobra S1 combo, a machine that is gunning aggressively for the industry leaders. At just $549, you're getting all of the same features as the Cobra 3 V2. You're getting touchscreen, 4 to 8 color compatibility, 255mm cube build volume, and built-in filament dryer. But at this price point, you're also getting a full enclosure with air purification, as well as the ability to print higher temp materials like ABS, nylon, and polycarbonate. Heck, you can even print PPSCF or other exotic composites if you just upgrade the nozzle. Plus, you even get AI failure detection, though personally I haven't tested it or gotten it to work yet. Again, this video isn't sponsored by Anycubic or by any other 3D printer manufacturer, but I include this in this list because, again, it is legitimately insane to see how much value you can now get for just $549. And it actually compares favorably, at least on paper, to older model combos that other brands are still selling for $1,500. But for roughly a third of the price, you aren't getting the same level of reliability as the leading brands, nor is the ecosystem as flawless or well integrated. And we're gonna talk about a lot of that in a few minutes. But hey, maybe you're not interested in multicolor printing. So how much printer can you get for 500-ish bucks then? Well, value-wise, it's hard to compete with the Sovol SV08, which comes in at just $569. And no, they're not supposed to look like this. I'm just currently converting mine into a fancy tool changer. For that price, you're getting a massive 350mm cubed build volume plus open source modability if you're into that sort of thing. Unfortunately, $569 is just the base version of the SV08. So if you want to take advantage of the ability to print high temp materials, you'll need to either enclose it yourself or buy an enclosed version for $728. And at that point, you might as well also add on the 5-inch HDMI touchscreen, which brings it to $797. Now, later on in the video, we're going to get into some insane printers with truly eye-watering price tags that make them completely inaccessible or impractical for any hobbyist to own. But fortunately, you don't need to shell out $1 million or more to use these types of machines for your next project, thanks to this video's sponsor, PCBWay. Whether you need a part 3D printed out of PEEK, MJF nylon powder, or even tool steel, PCBWay has you covered. They've invested literally millions upon millions of dollars into buying the best and most cutting-edge equipment that money can buy. And all you need to do is visit their website, upload your part, and select the process and material that you want your part made of, and they'll handle everything else and ship the parts to you anywhere in the world quickly, affordably, and with great customer service. So to check out PCBWay and save $5 off your next project, visit the link in the description or scan the QR code on screen right now. All right, let's get back to the video with 3D printers in the range of
$1,000 to $1,500.
At $1,000, we are now very much in the premium category, such as the Prusa Core 1, which comes in at $950 for a kit or $1,250 fully assembled. And let's be honest, at least on paper, it's actually less printer than the Cobra S1 combo. Smaller build plate, 300-degree hot end, no camera or multicolor functionality out of the box. So, why does it cost more than 2 Cobra S1 combos? Well, for starters, it's made in Europe or in the United States, not China, which definitely adds cost, but also brings some users peace of mind in terms of build quality, safety, privacy, and long-term support. Then there's the ecosystem. At this price point, whether you're buying from Prusa or their biggest competitor, you know the one, you best believe that you're getting a full ecosystem that's been designed to work together. We're talking firmware, integrated slicer, mobile app, cloud access, fleet management, branded filaments, and a very wide variety of spot-on profiles for every filament and nozzle size you could possibly want. Even an integrated model library that allows you to print directly from your phone. Prusa machines are also, from my personal experience, the most reliable and well-tested on the market. If you send a properly sliced print to this printer, 99 times out of 100, it completes without a hitch. Look, I've tested a lot of 3D printers over the years, and I wouldn't be able to say that for the majority of them. Then there's customer service. Prusa is the only company in the industry to have live 24/7 customer support chat in numerous languages. And that costs money. Finally, there's quality and longevity. Instead of plastic, the Core 1 is made of steel, PCCF, and polycarbonate, though some brands at this price point choose to use glass. And instead of releasing a new model every year and abandoning the old ones, Prusa is the only company in the industry that offers upgrade kits for older printers at or below their cost, or who continues to push firmware updates for 8+ years. These things might not matter to you at all, or they may be all important. I'm not here to sell you anything. But if you're wondering how Prusa gets 3 times as much for their printers as others that are, at least on paper, less capable, well, there you have it.
$2,500.
At this price point, we've basically moved on from your simple 3D printers. If you're spending this kind of money, you're getting much, much more. At the very least, you're getting dual extrusion, as in dual nozzle switching tool heads, rather than a more affordable but slower and more wasteful filament swapping system. But more than that, you're likely getting the ability to convert the entire machine into other types of machines as well. Take, for example, this, the Snapmaker Artisan, which ranges from $25.99 all the way up to $37.47. That sounds like a lot of money, but you're getting a lot of machine, which kind of makes it a sleeper bargain. Even at the entry-level version, you're getting a fully enclosed, dual extrusion 3D printer with a 400mm cubed build volume, which is way bigger than the flagship models from the other guys. But with the Artisan, that price also includes everything you need to convert it to a 200-watt CNC machine or a laser cutter, albeit a low-powered 10-watt one. Then, if we look at the highest-end package, you're also getting a 40-watt laser, a rotary module for machining or lasering round objects, and even an air purifier. You can even add on an additional 1064 nanometer infrared laser module for $449, bringing the total price to an eye-watering $41.96. But with that, you're pretty much covered with a large format version of every possible maker machine you could ever want. Yes, the Snapmaker is a jack of all trades, master of none. You might, for example, outgrow the relatively low-powered 200-watt CNC, or find that a 40-watt diode laser is less versatile than a dedicated CO2 laser. But in exchange, you get a pretty good all-arounder that can do most hobbyist work without requiring an entire workshop's worth of table space. I actually did an entire video with the Snapmaker Artisan showcasing its capabilities in the hands of a complete CNC noob like myself, so if you want to check that out, I'll put a link up here. Now, how am I going to get out of here?
$5,000.
Stepping up to the next price bracket, we have the Prusa XL, which sits right on the threshold between fiscally irresponsible hobbyist and professional, and is therefore probably the most expensive machine any consumer would ever buy. Technically, the XL, which includes all the perks we mentioned when talking about the Core 1, starts at just $19.99 for an open, semi-assembled single tool head version. But as I said before, if you're crossing $2,000 with a consumer or prosumer machine, you're almost certainly getting more. In the case of the XL, that means multiple tool heads, which allow true multi-material printing. You can get 2 for $25.50 or 5 for $35.50. But then you add on the enclosure kit, which I don't have, and factory assembly, and you're looking at $45.50. Interestingly, Prusa also markets an additional warranty, I guess because the complexity of the XL means that there are many more potential failure points, but that will now put you over $5,000. But hey, at least it comes with 5 kilos of filament, right? Yes, the XL is expensive, like really expensive. It's much more than the cheaper do-it-yourself tool changer projects available today. And yes, the XL had an extremely rough start before the profiles and hardware were perfectly tuned and dialed in. But these days, it has nearly the same reliability as Prusa's other machines, plus all the other benefits that we talked about before. It's also kind of the only game in town if you want a built-for-you 5-tool-headed machine with a warranty and actual customer support, at least for now. Make sure you're subscribed, because who knows? I feel like this is one of those technologies that is going to trickle down to the average consumer much sooner rather than later.
$10,000.
This isn't my studio, but come on, you guys didn't think someone was gonna trust me with a $10,000 printer, did you? So this giant machine to my right is the Prusa Pro HT90, and it comes in at the price of $9,990, or just shy of $10,000. It includes 2 hot ends, one ultra high flow for incredibly high speed printing, and another for your industrial grade materials, which can reach up to 500 degrees Celsius. The chamber itself is actively heated and filtered through an activated charcoal and HEPA filter, and it can reach an internal temperature of 90 degrees Celsius. And then the print bed, which by the way is 300 millimeters in diameter and prints all the way up to 400 millimeters, that can reach 155 degrees Celsius. All these high temperatures allow you to print industrial grade materials such as your PCCFs, but also small and medium parts in the very rare, very expensive, and very hard industrial grade materials like PEEK, PEC, and Ultem. It uses a high-speed servo to direct the air exactly where it wants it at any given time, which allows it to cool the area that has just been printed without air spilling over to other parts of the print and affecting the layer adhesion. One thing that I found interesting as I was talking to the engineers who built the HT90 is just understanding that the difference between 350C and 500, or the chamber temperature reaching 90 as opposed to the more common 50 or 60, that is not a linear approach. It is significantly harder, but ultimately, if you're just looking at the hardware, it may be hard to understand the price of the HT90, and that's where I think the role of the ecosystem and support come into play. They actually go a step further with their Pro line, but ultimately, and I think this is the major consideration, is going to be market forces. Printers that are as capable as the HT90, I'm told, usually go for 2 or even 3 times more money. And so Prusa is able to charge this price because this is a bargain for the capability that it gives you. If you want to reliably print PEEK, PEC, PCCF, and all of these engineering grade materials, you need a printer like this.
$100,000 plus.
Oh my, Philifam.
I have a feeling we are not in consumer territory anymore.
Welcome to the industrial zone, the space where we're not only no longer dealing with consumer 3D printers, we're dealing with publicly traded companies that don't even make consumer 3D printers. Now, in a second, we're gonna get to our grand finale, but I just wanted to stop really quickly and show you that there is a whole world out there far beyond FDM doing incredibly wild and mind-blowing things that just a few years ago were not even remotely possible. That's outside the scope of this video, but if you guys want to see a full video all about that and some of the crazy stuff that is happening in the commercial space, drop a comment below. All right, let's get to our finale. All right, fam, we have made it to the grand finale, one of the most advanced and capable FDM 3D printers in the world, the Stratasys F3300. The cost? Well, as you can imagine, it depends on a variety of factors, things like service package, configuration, but you're looking at spending around $1,000, making this printer more expensive than most houses. But why? Well, first, there is the build size, a respectable 600 by 600 by 800 millimeters. Needless to say, the entire printer is basically just a super accurate, thermally uniform oven, and it reaches 220 degrees C in the chamber, almost as hot as the extruder of our lowest end printer. You get 4 independent ultra-high flow tool heads that each reach 400 degrees Celsius, allowing this printer to print more exotic materials like Ultem, PEC, though interestingly not PEEK. Stratasys has other machines if that's your goal. Those tool heads are driven by linear motors, something that we've only ever seen in one prosumer 3D printer, and those offer a level of accuracy and repeatability that just isn't even remotely possible in consumer machines. We're talking as low as 0.067 millimeters. And of course, there are the 4 integrated filament dryers that keep your engineering grade materials very dry and very toasty at 120 C, which is far beyond what almost every consumer grade dryer can even touch. Not to mention all the smart systems and automatic calibrations that you could possibly imagine, including health monitoring and much, much more. But ultimately, what you're paying for in a machine like this are the business grade features. Everything we said when we talked about the previous printers in terms of ecosystem, premium service and support, those are turned up to 11 with a machine like this. It really is a one-click solution with almost 0 employee training required to operate it. But it also goes much, much further with things like built-in multi-level cybersecurity systems that are honestly way above my head. But above all, what you're getting is industrial-grade reliability and repeatability, capable not just of prototyping, but actual full-scale production. Whereas most consumer 3D printers tout their reliability across thousands of print hours, Stratasys tests machines like this for tens of thousands of print hours and hundreds of thousands of cubic centimeters of filament. This is an industrial machine made for industrial needs and industrial reliability. And that ultimately saves Stratasys' business customers downtime, failed prints, repaired costs, and most importantly, labor hours. So the bottom line, you buy a machine like this because you can't afford to tinker, mess around, or be out of service. By the way, I owe a huge thanks both to Stratasys Israel and to their local distributor, Supad, for filling me in and giving me the opportunity to film with these incredible machines. While I've been here, I've discovered a whole bunch of other crazy machines that do things that I didn't even know was possible. So if you guys are interested in a follow-up video where we explore the bleeding edge of other 3D printing technologies besides FDM, drop a comment below and maybe I'll be able to convince them to take over their showroom one more time. So there you have it, a look at the wide range of printers and price points on the market today. I hope that this video has been both educational and informative, and if it has, don't forget to hit the subscribe button and maybe give a guy a like while you're at it. Thanks again to the brands and companies who gave me access to their printers to share them with all of you, and to any manufacturers that I didn't include in this video. If you'd like to be included in future roundups or content, My door is always open, and you can find my contact info in the channel's About page. That's all for this week, but I'll see all of you on the next layer.